So, if we take into account the convexity, this is percentage change of bond price. This is D is duration. We also learned the duration. Duration is first derivative, and convexity second derivative. Then we will review this one, but this is called Taylor series expansion, basically, mathematically. So for the time being, you don't have to memorize it, but for the time being, let's take this as a given. Then we have a very interesting stuff over here. So E is positive. Okay, D is positive. Therefore, when interest rate goes up, if we don't take into account this one, interest go up, bond price goes down. This is natural, right? It is natural. It's obvious because bond is very discounted. The price of bond is discounted value of fixed cash flow in future. So if interest rate goes up, bond price goes down. That's natural. But then, as Yeonjung explained, since bond price is convex, okay, plain normal bond price convex. If we take there is a pricing error, and then therefore we have to take what of the secondary of the convexity. And if there is no, let's compare the case with convexity and without convexity. When dr is positive, this is negative, and this is negative, and this is positive. So it is okay, but we have dr square term and c is positive. Therefore, this is term is always positive. This is always positive. So therefore, we don't consider convex term. Basically, we always underprice bond, right? When this is positive, when dr is positive, and if we don't take into account this part, therefore this is too much negative. So we are overestimate negative price change. On the other end, if dr is negative, this goes up. But if we add this one goes up more. Therefore, if we don't add this part, then when interest goes down, we underestimate price change. So we still undervalue bond. Graphically speaking, okay, I think this is a good one. So if we approximate price change only with the first derivative, duration, then red line is the approximation. So when interest rate goes up, this way it goes up, interest rate goes down. When interest rate goes down, then if we see only duration of first order approximation, then price go down this path. But that is actually too much. In reality, price goes down only this part. So when interest goes up, if we don't adjust the convexity, we are basically overestimate price change. Therefore, we undervalue bond. When, on the other hand, when interest goes up and prices goes up in this path, if we use only first order approximation, but in reality, price should go up by this amount. So therefore, when interest rate goes down, if we do only first order approximation, we are underestimate price change. And then again, therefore, undervalue bond. Okay? It is so clear. Then that's the other part is the technical. Common people, convex and with that's the easy part, okay? And then let's go to this. So why don't you open your laptop? Did you bring your laptop? 랩탑 가져오라 그랬잖아. Yes, please. Yes. So let's review what we learned last week briefly, and then move to today's topic. So Wikipedia is great in summarizing, okay, binomial option price model. There is even step 1, step 2, step 3. Wonderful. Step 1, create binomial price tree. It is easy. We have original price. We can move, go up, go down, go up, go down. Then we can develop binomial price tree. And then step 2, find option value at each final node. Okay? So it means basically we have 2 binomial tree. One binomial tree for underlying asset, another binomial tree for option price. For option value, when we generate binomial price tree for underlying asset, we start from the beginning. When we calculate option price, we start from the end. So step 2 is find option price at the final node. And then step 3 is find option price at earlier nodes until we have time 0 value, which we learn. And then when we create binomial price tree, we need size of up move and size of down move. And then when we find option value earlier nodes, we need a probability. We need risk neutral probability. So that's what we need. And then I explained that T over N is dt in our previous case. So size of up move is du, and size of down move is d, and risk neutral probability looks like this. Okay. So, no question? Any question? 쉽죠? 김민영 학생 질문 있어요? 네. 네. 그렇지. 아, 원래 그런데, 그렇지. That's correct. That's why, okay. So, when we are at this stage, we are discount this value 1 time. When we are here, we are discounting this value 2 times. But this is already 1 time discount, so we can discount just 1 more time. Then it is basically discounting 2 times of the final one. 무슨 말인지 알겠죠? 그러니까 한 번씩만 해줘도 누적이 되니까. 예. 이전 게 앞에 걸 했으니까 나는 이전 것만 한 번 해주면 이렇게 저절도 되는 거지. 좋은 질문이죠. So, any other question? And then we have a challenge. One challenge is, what if there is a dividend? What if there is dividend? If we have a dividend, we have to change, okay, this setting slightly. And let's think about what we should do if there is dividend. The idea is binomial tree. The idea of the binomial tree is that, right? Basically, we have to assume, right? We have to assume that we are living in risk neutral world. And in risk neutral world, every asset should generate exactly the same return because people care only about return, right? Because every return generates exactly the same expected return, and we know risk-free rate. This means that every expected return of asset should be exactly the same to risk-free asset. Okay, that's what we know. But then, what if there is a dividend? Okay. So let me ask you a question. Suppose risk-free rate is 2%. Okay, risk-free rate is 2%, and then a dividend rate of an asset is 1% per year. So if the stock price is $1,000,000, okay? If stock price is $1,000,000, million is, yeah. If stock price is $1,000,000, it means that they pay dividend of $10,000 per year, something like that. Okay? So if risk-free rate is 2% and dividend rate is 1%, what would be the expected return of the price, stock price? The answer should be one of the three, right? If risk-free rate is 2% and then dividend of a stock is 1%, and my question is what would be the expected return of a stock price? And the answer should be either 1%, 2%, 3%, right? 1% means that 2% minus 1%, and 2% is that dividend doesn't matter. 3% means that risk-free. 2% dividend, 1%, so therefore stock return should be 3%. Something like that. So what should be the answer? 1, 2, 3. 1%. Okay. 2%. 3%. No? Why it should be 1%? Tell. Exact? Yes, you are right. So the idea is that, okay, so risk-free rate 2%. So it means that in risk-neutral world, every asset should generate 2% by holding that asset. But we already receive 1% by dividend. So therefore, expected return from capital gain, okay, stock price should be 1%. Then it should be fair. Okay? Then it is easy to determine what would be the risk-neutral probability. Okay? Suppose S is stock price. Okay, suppose S is stock price. Okay, and then suppose Q is dividend per dollar. Okay, so Q multiplied by S should be right. Should be value, final value, gross. Okay, Q is the gross. Okay, dividend rate. So QS should be final value, so because it is a gross, total should be gross dividend rate per dollar. Okay, so therefore, if we put S dollar in bank, our gain, okay, total return should be is what? Is R multiplied by S, right? Right? Because R is the gross risk-free rate, right? So if we put S dollar in bank, the total return is R multiplied by S, right? 그렇잖아. 왜 대답해? 예? 예? 지금 다 어렵나? Instead, if we buy stock, then total value at the expected total value is what? There is a first Q, okay, Q multiplied by S multiplied by U, right? And then we have dividend by the amount of Q, right? It is the same, but the only difference is that now we have Q, okay? So Q, in this case, small q is a probability of up movement in risk neutral, right? Which we have to determine. Let's say it is given, okay? When S is stock price, S multiplied by U is now our capital gain. But that is not the everything, not everything. We additionally receive dividend. So we have to multiply dividend, Q, total dividend. And when stock price go down, then which occurs with probability 1 minus small q and S, and this is a capital gain, and if we multiply dividend, then it is something like this, okay? And the risk neutral world, both of them should be exactly same, right? This one and this one should be same, right? Then we can actually solve it. So this one and this one is same. Therefore, we divide each side by S. Then R is equal to QSU plus QU BQ plus 1 minus small q S big Q. No, D big Q, right? So it means that R equals QU BQ plus 1 minus q minus d bq, right? And then if we solve with this one, then q is what? Q becomes then s minus q minus d minus u minus d, right? So it is almost same to previous case. The only difference is that we divide, oh sorry, this is not s, it is r, right? So the only difference is that, right, we divided r with q. So in this case, r is expected. In this case, r is the expected return of the asset. But since we have dividend, we should reduce expected return by the amount of dividend payment. Okay. So this is the only thing we have to change. And then because, okay, here r is exp r dt, right? Where r is continuous interest rate, right? Therefore, that's why we put this correlate something like this, okay, ddr, right? And then let's say q is q dt. Q is continuous dividend. So it is a simplification, right? If you have foreign currency, this is exactly setting. So let's say it is at each. So Q is in our previous 1% per year. If stock price 1% of value is paid out as a dividend, then Q should be 1%. Something like that. So if we set Q something like this as a continuous dividend stream, yeah. Q is greater than that, that's okay. Risk neutral probability can be negative at this case. Then of course we have to change U and D in the case. Okay. Okay, so you have a very good point. So in this case, R over Q. So let's go back to our risk neutral probability. So in order to make small q between 0 and 1, it means that R divided by Q should be between U and D. Right? Otherwise small q is not a probability. Right? This R minus a Q thing, okay? This one should be between U and D. Then small q is between 1. And then again we can think about the same story. What if R minus Q, R divided by BQ is between greater than U or smaller than D? Okay, we can think of it. If R minus R divided by Q is greater than U, then what happens? R divided by Q is greater than U, then even without dividend, okay? Even without dividend. Okay, without dividend, the stock return generate. Okay, if it's greater than U, R minus Q is that if we take into account the Q, okay, that's good, better story. If we take into account, it means that always high. Okay. Always low return than risk-free rate, right? Okay. So if R divided Q is greater than U, okay. If this is greater than U, U is the best case scenario, right? In best case scenario, so if we multiply by Q each side, then which means that R is greater than U by Q, right? R is greater than U by Q, which means that even in best scenario, and then if we best scenario, still stock generate lower rate than risk-free rate, even after dividend, right? So if we hold, we receive a dividend and the possible price gain, and if we add them all, then still expected return is less than risk-free rate, then we have no reason to hold the asset. So that doesn't make sense. We have arbitrary opportunity. What if R divided by Q is less than D? Okay, then which means that R is less than D multiplied by Q, which means that in worst case scenario, our return from capital gain plus dividend is greater than risk-free rate, even in worst case scenario. Therefore, everyone wants hold the stock. So again, that does not make sense. There is arbitrary opportunity. Therefore, R divided by BQ. We always between U and D. If R divided by Q is between U and D, then it is always between 0 and 1. Risk condition is always 0. So that is okay. But still, the same story. If there is no arbitrary opportunity, Q is between 0 and 1, right? Then there is, which means that there is risk neutral probability, which means that there is a risk neutral world, and then therefore we can do risk neutral pricing. Okay, let's go back to this one. Okay, so if we assume continuous, okay, continuous risk-free rate and then continuous dividend rate, then R minus Q is simply EXP R minus Q dt. Okay, it should be something like this, right? So we can slightly change our model, such that dividend rate, okay, continuous dividend rate. Let's say it is 1% per year. Then all we have to do is to change this risk neutral probability of this one. C2 divided by C2 divided by, okay, let's say EXP, okay, EXP, this one, multiplied by DT, and done, okay, and then we have a slightly less risk neutral probability, okay, slightly lower risk neutral probability, and then everything should be same. Good? Easy. So if we include it, it still is very easy. Okay? So please update your spreadsheet and observe how stock price changes. Yeah, so this one, we use this one. Yeah. Yeah, so, you know, it's divided by Q. So expected of expected. Yeah, this one. We are just applying this one. Big is exponential of small QDT. So. Is everything okay? Here? 월트 디즈니 가격이 그래서 얼마가 나왔어? 그거 아니야? 아, 그럼 재미없지. 님 걸로 해봐야지. 네, 월트 디즈니로 해봐요. 월트 디즈니로 했을 때 아메리칸 옵션하고 유로피안 옵션하고 가격이 똑같이 나왔죠. 이제 디비던드가 있으니까 가격이 달리 나올 수도 있어. 한번 해봐요. So without dividend, European call option and American call option price are same. But if there is a dividend, now American option and American call option and European call option price can be different. Actually, if there is a dividend, then the value of American option can increase. Actually, value of American option can increase. No. Actually, if there is a dividend, it is more likely to exercise American option earlier than at the final period. Do you think why? 해봤어요? 네? 아, CSV를 조정해서 다 깨졌구나. 그럼 안 되지. 어휴, 처음부터 다시 해야겠네. 아이고, 어떻게 하나.
I think I found the mistake why the spreadsheet didn't work. In American version you say point, and in Germany you write it like a comma.
Oh, really?
Yeah.
Wow.
So I think that was the mistake last time probably.
In German, why they use comma instead of?
Because we're the Germans.
Wow. Okay. I see. The German way of doing mathematics. Interesting. Yeah. Is everything okay?
Yeah,
Yeah, yeah. So you can press. Good. Let me get a little bit. So let's compare. Okay. In the option model, this is the European option, and this is American option. This is the European and American option price. And then it looks like this. And if we change dividend rate as 0, yes, they will go down. Okay, so I have two cases. So, okay, let's take a look at this spreadsheet. If there is a dividend now, European option, American option price is 11.5151, and European option price is 11.46 with dividend. No, it is actually put option, I think. In my model, it is put option. Yes, it is put option. Okay. In this my example, okay, with dividend it is 11 something, and then if we make dividend rate, suppose there is no dividend there 0, then put option price go down. This is why. Why put option price, both American and European option prices go down if there is a dividend? It goes up if there is a dividend. Why both European and American option price go up, put option price go up if there is dividend? Why? No, discount factor, discount rate doesn't change. We always discount it with risk-free rate. So it's not related with discount rate. Why? 여기는 아직도 잘 안 되고 있어? 나중에 해? 에? 처음부터 다시? 나중에 해요, 그러면. 네. 나중에 해봐요, 다른 거. So, yeah, again, the question is why, put option becomes more valuable when stock price go down, right? And then if they have a dividend, if there is a dividend, it means that stock price should go up less by the amount of dividend. Therefore, we are better off. Yeah. Is it too obvious? I think it's too obvious. And then in case of call option, okay, put option is not fun. In case of call option, American, if there is no dividend, American and European option prices are same. But if there is now a dividend, then European option and American option can be different, which means that if there is a dividend, there is a possibility that call option is exercised early. Right? Which means that the only difference is dividend. Okay, I think I can show you. Okay. So this is put option. Okay. So this is American put. This is European put. And then let's say American call. American call. And then European. Okay, so let's start from European core. So European core is exercise. European core is max. Okay, stock model. This one minus exercise price. Okay. Okay, something like this, and then you can do it together. Okay, you can do it together. So the call option price is now we can get a expected price is this one multiplied by risk neutral probability plus this one multiplied by 1 minus again risk neutral probability. Okay, so this is the expected value, and then we have to discount it back. Discount it back with discount factor. Okay, this one. We can bring this. Okay, so European call option price is this one, and then American call option price is okay, final price is same. Okay, and then this one is we recycle this formula. Instead of F22 and 15, 16. Okay, so this is the American call, but in case of American call, at every period we have to compare this continuation value with the exercise value right now. So max. If we exercise right now at this point, this one minus this one. Same. Okay, so when dividend rate is 이상하네. Okay. Okay. When dividend rate is 0%, then they are same. Let's increase the dividend rate to 2%, 5%. No, 5% there is arbitrary opportunity. No, it doesn't make sense. So let's increase the continuous rate as of 5%. Okay, 5% and then dividend as 2%. 그래도 가격이 똑같네. 예. 바뀌었는데. 02. Okay, I think it is because it is yeah. So we have a slight change. Okay. Okay, so okay, when dividend rate is 0, basically European and American call option prices are same, which means that even if there is this American option, an option is not exercised until maturity, it is better to hold it. But if there is dividend rate, let's say it is 3%. Risk distribution, okay, everything okay. Then now American option is more expensive. Okay, I mean slightly more expensive than this one. Which means that if there is a dividend now, without dividend, the European call and American option price are the same. But if there is now dividend, then American option is more valuable. Which means that there is a possible state in the tree somewhere that it is better to exercise option earlier than later. Why is that? So why? So it means that in case of dividends, then American option is more likely to be exercised earlier, right? That's why it makes American option more valuable, right? Then it is why. Why if there is dividend, it's more likely that American call is exercised earlier? Why is that? Because, okay, let's think of it. Suppose you have a dividend, then suppose you know a stock will pay dividend tomorrow, okay, tomorrow. And if you have American option, that what are your thoughts? If you exercise American call option right now, what happens? If you exercise the American call option, then you pay money and you receive the stock, right? And if you have stock now, you have right to receive the dividend tomorrow, right? So if there is a dividend, American option is more likely to exercise early, okay, early, because by exercising option you now have a right for the dividend, so you early exercise become more valuable. No, not more security. Now you have more money. Okay. By exercising option you have stock, so now you have become stockholder, you can receive dividend tomorrow, right? So it is better to hold the dividend stock than just holding an option. Therefore, you are better. And then we can have a reverse thinking. Okay, if there is no dividend, then you can guess why American call and American call option price are same. Because there is no dividend, there is no benefit of holding the asset early. Okay, because by just having the stock, there is no positive benefit of holding the stock, right? Because there is no dividend. But if you hold the stock right now and exercise option, you have to pay money early, right? If you don't exercise call option, you can keep delaying paying the money and receiving stock, right? Then you can basically save financial cost. Therefore, if there is no dividend, then you don't want to exercise option early because you don't want to pay money early. And then because you don't have any benefit of holding the stock, or keep delaying until to the last moment, and then you can exercise. Therefore, it is better to exercise late up to terminal date, then it becomes no difference. There is no difference between holding European option or American call, or European call option and American call option. Therefore, European call option price and American call option price is the same. Is it okay? Yes.
So is the price of the American call option weight American call option. Price is higher. What do you think is your personal arbitrage advantage? Understand what
Yeah, so if you think stock price will go up, okay? You mean that's your question?
the question is if the price of the American call option
Price of the
reflects the advantages of American compared to European.
yeah,
Why do you
exactly.
still buy it?
Why do you still buy American call option?
Well, if you buy a stock, you think it will go up. If you buy the call option, you also want to have an option to receive extra money. The American call option is more expensive. And
Okay.
the price should reflect the advantage as over a European option. So why do you still get the American one if it's more expensive?
Okay, first, if there is no dividend, it doesn't make any difference whether you hold American or European because the price are same. Okay, and the only reason why American call option is more expensive than European call option is because there is dividend. Okay, so actually when stock price goes up, then of course it is good news for call option holders. But in addition to that, if you have American call option, you have additional benefit that you can exercise option early and you receive stock early, and therefore you can receive dividend more. Okay, so it is more advantage. There's more advantage holding American call option than European call option. Therefore, but American call option should be therefore more expensive than European call option, and it is more expensive by the exact amount of the value of the future dividend when you exercise option early. So anyway, market is equilibrium. So in the end, there is no difference whether you hold American option or European option or underlying asset. In the end, in risk neutral world, expected return of every asset should be exactly same anyway. And then if in real, even if the real world, if once you adjust risk, we will learn that later. Once you adjust risk, anyway, risk adjusted return should be same for all assets. So it doesn't matter. It only depends on your preference and your hedging objectives.